Hi, today we will have a session to develop a payment system design. In this interview, it's a mock interview session, and we must solve three tasks. First task, we must create API to store users' credit cards in the online store. Users database already exists. We don't need to modify tables. Example of the table is ID. It's probably integer, and email it is string. Second task is to create an API to make payments for items using either a stored credit card or a new credit card. Items already exist. We don't need to modify this table. Example of the item is ID, one integer, price 100, and name string. And third, we must create an API for admins to view each user's total spending per day based on completed payments. As a bonus, we must calculate storage for 1 million users. Okay, let's start. First, what I want to do is, we must solve this first task is create API to store users' credit cards. And I will create some shapes. And this shape is, means we have UI, API, UI calls API, and API calls SQL database. And this is the simplest diagram. And we will discuss later how to improve it and scale. Yeah, I must describe API for and API endpoints for credit card storage. That means we have post request, which user will send post request to create a card. This post request has body, headers, and some response, body and headers. In request body, we have card number, with type string. It is required field. We will have expiration date, It is also string and required. We have security number or CVC, CVV. It is also string because it can start with 0 and we cannot use integer. Probably we don't have any other information. In headers, we will have something like a user token to authenticate user. For this task, we don't need authenticate user or create authentication service. But we shouldn't use user ID in request or something like that. Response body. Response has 201 code. It must be in response headers. And code will be, the 201 code means created. And in response body, we probably will have something like ID. We don't need any other information. Probably to display a list of cars, yeah, we can return card mask. And expiration date to identify the card and use it for the next purchase. I will remove response headers and I will describe some other codes that we can use in our API. For example, code 400 means that something wrong, and we have in response we have error and something invalid. For example, card number is invalid. Or user forgot to add expiration date or security code. Security code, not number. 400 error means invalid, and 401 means the user, for example, had expired token. That means user unauthorized or unauthenticated. Also have code 404, but probably for us, it's enough to have 2 error codes and 1 success code. Okay, for the first task, I described request. And also I want to describe database structure. This is endpoint. That means we have cards database table. In card database table, we have ID. For this task, I would choose UID and probably V4. UID V4 looks like something like this. It will return unique identifier, and the benefit, for example, if we use integers, we can find a card with ID 1, 2, 3, and it's easy to hack. It's easy to find how many cards we have in the system, and it's less secure. And UID allows us full uniqueness because amount of UIDs is similar to amount of sand in Earth. Okay, ID is UID, and it is our primary key. It must be not null. Okay, we cannot, for security reasons, we cannot store card numbers, and we use a system like Stripe to store this number. We only can use what a Stripe returned to us. It's a card mask. It must be a string, but in database we have varchar. And because we have limited amount of string, for example, it is example of this mask will have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we can use varchar 8 or varchar 20 just to add a little bit more space. It is not null field. We can store expiration date to allow users to see, because potentially they have this, they can use the same card or the same, like little bit different card, but with the same numbers at the end. And to identify that this card is desired card, we have this date. We can store it like actual date, not stream. And first, for example, for each date, we can assign, okay, this card will be expired at the end of the each month or at the beginning of each month. But yeah, we can add a day to this. And yeah, it's an example. It will be date, type, and it's probably not now. We can store security codes, of course. We have some technical fields like created at, timestamp. It must be also not null. Also, technical field is updated at. Yeah, this is enough for beginning. I probably must add some indexes, but it depends on what required for the next task. We will return to this later. Okay, the second task, I will create a topic for this mock interview. It's a payment system design. More with a little bit bigger. Okay, second task. We must create API to make payments for items using either a store credit card or a new credit card. Yeah, in this task, I will also describe an endpoint. It will be much faster. Okay, we have payment and we must create it. Yeah. In the request body, we have ID of card and it will be string. And it must be optional. Because we can use stored card or we can use already created cards, or we can create a card as a new card. What does it mean? It means we can reuse structure. Yeah, I will change a little bit color here to identify different yeah, that means okay, we have card ID, it's optional, or we have card object, which has a number, expiration date, security code, and this object is optional. And we must provide card ID or this object. Request header already has the same user token. Response code must be 201. It has ID of payment. Also, we can return card. We'll have ID string. In also code 400 with something invalid and user not authenticated. I forgot to add actually In request body, we have cart ID. Also, we have item ID. It is string as it is required. Yeah, user selected item. They use saved cart, and it will create item database table. Database entry. Also, we must have a payment database structure. Our payment has ID. I will use UID. It's the primary key. Of course, it's not now. Primary key cannot be like nullable. Payment has item ID. It is also UID. It's foreign key. Also not now. We have card ID are the same. Foreign key and UID. Also, we have price because in items we have some price inside the database table, but this price can change, and we must save inside payment. We must save the current price of the item. And price, I would use price cents. It is integer. Not null. Why to use integer? Because in most of tables, database programming languages, for example, if we use price, something like float, we can calculate float, and it will return something like 0, 3, and lots of nulls. And for example, for lots of languages have the same problem. Using integer like 1 cent plus 2 cents is equal 3 cents. You don't have this problem. Also, sometimes you have lots of calculations, and floats or doubles have something at the end, and using integers we can avoid it. Probably we have price currency, but for this task probably we will use only one currency. It's not international store. Also, we will have some tables. We will have some technical fields like created it, updated it, and some indexes. But I wouldn't use indexes now because it depends on what user want to see and how to search by this. Table. Okay, the third task is to create an API for admins to view each item's total spending per day based on completed payments. Yeah, okay, we have API in our system, and now we have another service. It's admin service. And this is probably payment API. Payment admin service will have their own admin SQL database because we using domain-driven development, and we don't want one domain to have access to another domain. Communication between payments, between these two systems, will be with some message broker. In this example, we can use Kafka. Or AWS Event Bridge or something. It means payment API send request to this. Message broker, and message broker send it to API. If you have 3 services, 4 services, all communication will be between one message broker. Admin API sends request to admin database and to save data. Okay, we must create API for admins to view each user's total spending per day based on completed payments. That means in payments, it's good to have some field like date. It must be not technical field, it will be business field. And I would use date as data type, and I will use it not now. And because we search by date, I will add index by date. That means B3 index. B means balance tree index by date. I don't think we must use other indexes, but idea is I don't want users to create payments for the same item multiple times. That means I will use some idempotency key token. It's a, for example, UI token or checkout token. And if user will try to create the payment again with the same checkout token, we will raise error because this checkout token must be unique. And I will add it to our database too. For example, it can be varchar 20, not now. And I will add unique index by checkout token. Okay. Let's describe API for admins. But before that, we must understand what data we will send from payment system or for payment service to admin service. And I will add SQL query to understand what we want to send and what data structure will look like. I must select probably, yeah, I must select date from payments and some other information. I just trying to think. Also, I forgot to add each card belongs to a user, and we must add user ID to database structure. That means we already have, in payments, we have cards, and all cards are connected to users, and we can find users. And probably we must select a user. Okay, we must select date, user ID from payments. We must join cards on cards.id equal to payments.card.id. We must join. This join is an inner join. But in Postgres, I selected Postgres. We don't need to specify what kind of join, because if it's not a left join, we don't need to specify. Okay, we must join users on users.id equal to cards.user.id. And I already see that we use card ID and users ID to search. That means in payments, it's good to have index by card ID. And we already have an index. No, we don't have it. Yeah, I will create an index by user ID in our cards. Yes, okay. We already have users. We joined users. We joined cards. We can select date of payments. We can select user ID from cards. We must group by user ID. I can make a mistake in this SQL. Yeah, I will do something like group by payments date and cards user ID. And that means we have payments joined by date and by users. And we must select some of price cents. To make this request very safe, we can add some limits. For example, we want to see hundreds of users, and we can use offset. It can be from 0 to 100, and then 200, 300. It means we have pagination. Also optional, if admin wants to see the specific date, and we can add condition where date equal to or date between for example, the admin want to see only payments in these 3 days. Okay, I understood that we have date, we have user ID, and we have some sum. Probably this sum will be payment cents. And my database table for admins was like reports, admin reports. Yeah, probably will have the same structure. Okay, database structure, payment reports table. We have ID of this report, we have date, ID, user ID, price, and date, and some technical fields created. And I must add index by date, I must index by user ID, and I think it's enough. And our API will looks like for admin service, we'll have only one GET request. Get payment reports. And this request doesn't have, GET requests don't have body, they have parameters. And in parameters, I will use something like date from date to I will add some filters by user ID and I must add limit and offset. Request header has admin token to authenticate the user. Response will have 200 code. It means success. It will return array of reports. And in this array of reports, we will see date, price, not price, it's like total price of all items user bought. It will be integer, like 100. And user ID. As errors, something invalid, probably if date is, for example, date from is bigger than day 2, or other errors, user ID doesn't exist, is for if error 401, for 404. And we have 401 user admin not authenticated, and 403 admin authenticated, but admin role is different. For example, admins have different roles and different permissions. And in this situation, our payment API will create a message to admin, send it to Kafka. But actually, I would create a worker here. Cron job that will asynchronously create this report and send to message broker. For example, this task will be executed every morning at specific time. It's one idea. Second idea, if admin already calculated something, for example, they had report for in 1 month for million of users, we can use admin UI. We must have admin UI. That sends request to admin API. And first it sends request to bits before SQL is use cache. and I would use Redis. And only if cache returns something that reports are empty, we are going to SQL database and make some query to fetch it. And I believe this is enough for our payment system design. I believe we covered everything, 1, 2, 3. As a bonus, we can calculate storage for 1 million of users. Yeah, let's do it. First, I want to calculate amount of for cards. For example, we have for one card we will have 1 million cards. For one card, we have limited amount of fields. For example, ID is 4 bytes plus card mask is 20 bytes. Expiration date, I would use 4 bytes. I'm not sure. We must find this information in the future. User ID is 4 bytes. Created and updated ads also by 4 bytes. Okay, we have 24, 32, 24, 28, 32, 36, and 40 bytes. And for 1 million users, we will have 4 million bytes, which means 4,000 megabytes, which means 4 gigabytes. The same we will do with another database, but I think it's enough for us to understand that, for example, for roughly we have 4 gigabytes for cars, about 4 gigabytes for payment, and about 4 gigabytes in admin. It's not a big amount of data, but if we have 1 billion of users, for database, we can use something like read replica and write replica. And if you want to read something, we read from read replica. For example, our cron job will go to SQL read replica, retrieve information from it, calculate, and send to our admins. Admin SQL database also can have read replica to make some big SQL queries, but I think it's enough for us. Yeah, for example, if we have a billion of users, we can, instead of one payment API, we can use payment API cluster. Payment API cluster will have multiple payment APIs instances. I will show you something like that. but we cannot just send requests to, like, we must understand how to use payment API. What API we must use, first one or second one? And in this case, we must add a load balancer. With round robin algorithm. That means user sends request from UI. It sends request to load balancer. Load balancer understands, okay, previous request was to payment API 1, and I will send this next request to payment API 2. After that, we go into forward request to read replica to retrieve payment, for example. If payment not found, okay, it's okay. But if we want to save payment, we must use write replica. For admin, we have like limited amount of admin. We don't need load balancer or payment API. I mean cluster. If you want to retrieve lots of data, we can use before even load balancer. For example, we want to create and retrieve 1 billion of payments. Like we have CDN. And first request will be to CDN. If CDN didn't return us cached data of payments of cars that we saved, we're going to load balancer that go to API and then retrieve the data. If it is like hundreds of billions of payments and cars, for example, instead of using SQL database and replicas, we can try to use data warehouse. But for this system, I believe it's enough. Okay, thank you for having me here. Today we described how to create payment system design. I described how to create API, how to calculate database storage. Lots of ideas of how to do data structure, how to understand what indexes we must use, and how to scale the system.